Hi there. Today we're going to discuss the block diagram representation of um, of discrete um, time system. All right. That's our topic today. Before we begin, I'm going to emphasize this quote that simplicity is the key to brilliance. This quote has a relevance into our topic for today. Okay, the first question would be why we need to study the block diagram representation of discrete time systems. Because complex systems can be much easier to understand, and it would be much easier to explain the the complex systems. So without showing a lot of equation and also explaining a lot in details using the word. So block diagram representation is an efficient way to explain how will the input affect the output of the system. So that's the importance of block diagram representation. Okay, so we're going to have some basics of um, block diagram representation, and the basic would be this one. Okay. Mhm. Okay, so basics. Mhm. Basics. Okay, so um, to begin, so using a constant, so if x of n is equals to um, a's of x of n, how will you represent this in block diagram representation? The answer would be this. A. Okay, so that's the a x of n. Okay, so that's our number one. So if there's a constant, so a is any number. Okay, okay, so number two. Uh-huh. So number two is addition. Okay, so x of 1 plus oops, mhm, plus x of 2 is equals to y sub n. So how will you represent this? It would be um, x of 1, okay, plus addition x of 2 n to y sub n. All right, so that's the second one. So you could just replace it by you know um, multiplication. It can be replaced by um, multiplication um, minus. So that's so you will just change it also. Okay, so that's the second one. So the third one would be okay. So the third one would be this. Okay, so the third one would be the delay. So just remember, this two doesn't require a memory, but this one requires a memory. Okay, so um, x of n is equals to wait wait mhm. So assuming that our y's of n is equals to um, y's of n is equals to x n minus 1. Okay, so how will we do this in block diagram representation? So it would be x of n, okay, and then z negative 1 to um, y's of n. Okay, so it's easy. You will just you know bear with this one. Okay, you could also change this. For example, so that's the A. So the B would be um, y's of n is equals to x n plus 2. So it would be, so it's easy, x of n, okay, z 2, okay, and y's of n, okay. So that's it. So we're ready to have some example. So our example would be mhm, this one. Okay. So this is a simple recursive system, okay, with an input and output equation. So we're going to apply the basics here. So the input would be x of n, okay, okay, x of n, and then we put an arrow. So it doesn't x of n does not have a constant, but we know that it is separated by an addition. So we're going to put it that, and then the y's of n. However, we're missing this one. So to do that, we're going to have some like this. Okay. So we're going to add the a, and then remember that when there's a delay, um, what we did is negative 1. Okay. And then and then so that's our block diagram representation of this one. So we're going to now we're ready for a much difficult um, example. So the example would be okay. It's my first video to you know have this digital pen or tablet pen. So that's why bear with me for this simple mistakes that I kept doing. Okay. So this is a difficult one at first, but when we apply those learnings that we have, it is much easier to deal with. Okay, so let's go first with our equation. So as you can see, it's there's a lot of input, and also I mean there's only one input. However, we have those just like what we have on the first example on the input and output equation. Okay, so to do this, we're going first to separate the output in the equation so that it is much easier to understand. Okay, y's of n is equals to positive 3y. I'm just going to transpose it plus 4y n minus 2 plus x of n. So as you can see, there's a lot of plus. So we have already learned on how to do this one. So 2x and minus 1. Okay. So what we're going to do here is we're going to have this block diagram representation. So first, The input is x of n, by the way, and the output would be the y's of n. Okay, so to do this, so x of n, okay, so that's the input. So there's a plus here. Okay. Oh, wait, we're just going to remove this. Okay. And okay. hmm So that's the plus. However, we have this 2x. Okay. 2. And then a delay. Say -1. And then okay. So we've dealt with this one or this one. So the things we were going to deal would be this one. Okay. Okay. Going to have a plus there. Y's of n. And then so there's a constant of positive 4, and then z minus 2. Okay, and then there's a plus here. Okay, and then 3 with a delay of 1, and then put it here. So we add those, and then after we add those, we're going to bring back here. Okay, so that's our block diagram representation of this one. So today we learn a lot of things about you know block diagram representation. So just to give a review, so this is the basics that we've learned, and also this is our example, and this is our second example. So you're confident to deal with a block diagram representation. So that's it. I'm Jerome, and have fun learning digital signal processing. Okay, so if you learned, hit the thumbs up and then also subscribe for more video. Thank you for watching.